do the second part of 6.5. Let me get it to open. Okay, so let me hide this. Okay, so a 3 by 3 matrix is A sub 1, B sub 1, C sub 1. And then we have a row of A, B, and C again with their subscripts being 2. And then we have a third row, which would be like the third equation, right? And it's also A, B, and C. Their subscripts are 3. Now, this would be the most common form, okay, because we wouldn't do like A, B, C, D, E, F, G, H. Like that's too much, okay? For the determinant, also, the form that I have listed is going to be the form that is used and the form that you will see. What you do, okay, so you're going to, I'm going to read this right here real quick, okay? You're going to take the column values in your first column, right? So this would be my first column. I'm going to take those values. And if you notice, it's A sub 1, A sub 2, A sub 3. It's all my A values, right? So I have A sub 1, A sub 2, A sub 3. Okay, so that's what I mean by take the column 1 values and hide, quote unquote, y'all, hide its row and column. Okay, so let's go ahead and let's just look at this as an example. Okay, that A sub 1, and then if you notice right here, I'm taking the determinant, right, of the remaining values. The way I found those remaining values is I hid the row and the column. I'm looking at A sub 1. Here's A sub 1, right? I'm just going to highlight it, y'all. I hid the column and the row. So this one's actually, I said it opposite of what I highlighted. I'm not talking about A sub 1, right? I hid its column and I hid its row. You can use your pencil, you can use whatever you need to, as long as you can see that what's remaining, right? What you can see is B sub 2, C sub 2, B sub 3, C sub 3. B sub 2, C sub 2, B sub 3, C sub 3. Did you see that? And I got that from taking all of the values in my first column and then individually hiding their row, hiding their column, what's remaining. That's what you take the determinant of. I'll go ahead and show you all this one too when we're talking about right here at A sub 2. This is A sub 2. If you hide the column that it's in and the row that it's in, what's remaining is B sub 1, C sub 1, B sub 3, C sub 3, B sub 1, C sub 1, B sub 3, C sub 3, right? Do y'all see that? And then similarly, you'll do the same thing for A sub 3, okay? Okay, so take column 1 values individually, right? We're going to hide their row and their column. The values that are exposed, the values that are remaining, the values that you see that you didn't cover up, however you want to say it, right? We're going to find the determinant of those remaining values. And whenever you do this, what we do is we actually alternate the negative and positive sign. So here I notice that my leading coefficient, right, my leading term is positive, and then I have negative, and then I have positive. If we continued in this manner, we would have negative, positive, negative, right? We're going to alternate them, okay? Let me see what else. So what we're doing is we're finding the determinant, right? And finding the determinant of a 3 by 3 matrix is also called taking or using minor determinants, because this is a little minor determinant. And taking all 3 of those small determinants is what will actually answer this problem for us, okay? Okay, so let's do it. Problem 1, what we have is 5, 4, 0, negative 1, 1, 0, negative 2, 3, negative 1. The first thing that we're going to do is let's just go ahead and, because we're finding the determinant, right? Let's just go ahead and list the column 1 values. I don't like the width of this pen. The column 1 values, y'all, this is column 1 right here, okay? And those values are 5, comma, -1, comma, oh no. Y'all, what do I keep pushing? It's going to happen, just so y'all know. And then -2, those are my column 1 values. Now, the directions told me to use those values, hide their row and their column, take the determinant of what's remaining, right? Making sure that with each time that I write down a new column 1 value, I'm alternating between positive and negative, positive and negative. So this tells me that what I do is I take 5. The determinant right here is going to be determined by hiding row 1 and column 1. And what remains is 1, 0, 3, -1. And then I'm going, since that was positive, right, I'm going to do a negative, look at my second column 2 value, which is a -1, take the determinant. If I cover up column 1 and row 2, what ends up remaining is 4, 0, 3, -1, close that. Now I'm back at a positive. My third column 1 value is a -2. Take the determinant. What would be remaining is 4, 0, 1, 0. Okay, so if y'all want to go ahead and pause the video, what you'll do is you'll individually solve each determinant, and then afterwards you'll multiply it by the coefficient that's out in front. Go ahead and get your determinant, and then you can go ahead and watch me do it. Maybe just check yourself or something, okay? Okay, so what I'm going to do is I'm actually going to start using some brackets, and I'm going to do 5. This is going to be times the determinant that I get here, okay? So looking at this, I know I'm going to take the product of the two diagonals. What I'm going to have is 1 open, -1. That's multiplying them. I'm going to subtract from that 3 times 0, and then I'm going to go ahead and close my bracket. If you look right here, what I have is a negative times a negative. Since those signs are the same, it's a positive. It's the number 1, y'all. So I'm just going to open up my bracket. Taking the product of the two diagonals, I would have 4 times a -1, subtract from that 3 times a 0, close my bracket. I notice that I have a positive -2. Those signs are different, so it's actually a -2. Then I'm going to open up my bracket. Wish I could just double tap it, boom, go right back to where you were. That's all weird and blurry. I'm going to open up my bracket, and I know that what I'm doing here is I am taking the product of the two diagonals, which would be 4 times 0 minus 1 times 0, close my bracket. Now let's go ahead and work within the brackets. What do I have here? Okay. Sorry, I was looking. I ended up not saying equals D, and so it didn't look like the problem was complete, and I got confused. Okay, so now working within these brackets, I have 5. This is going to be times. You could do a parenthesis here. It's really up to y'all. We're going to stick with brackets for now because I'm really not done simplifying the inside of the brackets, right? So let's go ahead and do this math. If you do 1 times 1, you get 1. Signs are different, so it's -1. And then 3 times 0 is just 0. We can go ahead and do a -0 there if you want to. We'll add to that right here. 4 times 1 is 4. Signs are different, so it's negative. 3 times 0 is 0. And then we're going to subtract 2 times 4 times 0 is 0. 1 times 0 is 0. If you notice, having these zeros really come in as a big help. Just continuing to solve this problem. I have 5. -1, -0, signs are the same. You add and you keep. I'm not even going to write my positive just yet. I'll go and do it. Okay, so then inside of that bracket, I have 4 and a 0. Signs are the same. Add and keep. I've got a -2 times 0 minus 0 is just 0. So 5 times 1 is 5. Signs are different, so it's negative. A positive and a -4, those signs are different. I get a -4. Then I have a -2 times 0. That goes to 0, correct? So -0. Technically, I'm really just looking right here at my -5 and my -4. Those signs are the same, so what you do is you add them and you keep their sign. That is your determinant. Okay. Let's go ahead. I'm trying to see. What is that one? Quiz 2 and 3 solution. Okay. Let's go ahead and do this last problem. I just have the problem written down. I haven't solved it. And technically it's because I wrote it down and decided I didn't want to do it. Is this one here? Did I decide? Okay. Well, that's good. Past me and the present me decided at the same thing. I don't have the answer in front of me, but it's worth doing. It's just another example. Okay, so I want you to notice something. In this problem right here, if you look at the form, right? So it's already written in a determinant form, and it's already written as a 3x3 matrix without any without any variables, right? So really clear and easy to see what we're doing here. I actually want to make sure that whenever I take the determinant of a 3x3 matrix that it's in this form. So when it is not in this form, let's go ahead and put it in that form. This would be written as, we have our determinant bar, right? And let me go ahead and just do that top row. I've got 1x, 1y, 1z. So 1, 1, 1 equals 0. And then, I wonder if I wrote the problem down wrong. That just looks weird, doesn't it? And then right here, I have an x, I have an 8, a -1, a 1. Why'd I do that? Did y'all question me? If you did question me, you should have questioned me. Okay, that's what's different with this problem. Okay, so here I have how to find the determinant, right? So I didn't read that direction first, y'all. I need to read the direction right here. Did y'all see it? Clear as day. I just deleted it. Did y'all see it clear as day? Use Cramers rule to solve. Yeah, I didn't even pay attention to that. So let me actually not write it in this form. Instead, let me show you again that when you use Cramer's rule for this matrix, I'm really just trying to figure out, it said 3x3. This technically ends up being a 3x4. So let me solve this. I do have written down how to find x and how to find y and how to find z, but unless I know for sure, like, is this even in your homework? You know what I mean? I don't want to do something because our work actually explicitly stated a 3x3. And this right here has 3 rows and we have 4 columns. So this would be a 3x4. 6.5 says to do a 3x3. So I don't want to do this yet. It is solvable. It's completely solvable. But we haven't actually gone over how to do this. So instead of just talking about it, let me end this video and I will go ahead and look up the answer. Okay. Thanks, y'all. Bye.